In this lesson, we shall talk about two things: scalar multiple rule of differentiation, and then we will look at addition or subtraction rule of differentiation. So let's start with the scalar multiple rule of differentiation. If a function is given as f of x, all right, and there is a scalar multiplying the f of x, how do we differentiate this? So you take d dx of the function that you are about to differentiate. Then what you do is that you pull the constant, which is the k, you pull the constant out. So you have k out, then you are left with the differentiation of the function f of x. Okay, so we shall solve some examples to see how this is done. Example 1. Given that y is equal to 2 raised to the power 4. Okay, now this, we have a scalar which is 2 multiplying a function. So the first thing that we do when we are differentiating this is to pull the 2 out. Okay, so when you pull the 2 out, then you are left with the differential of the function. Okay, remember in our introductory video to differentiation, we said when we are differentiating a function, we first let the power come down. Okay, so that is 4. Then you write the function, which is x raised to the power 4. Then subtract 1 from the power. Okay, but remember that we had a constant of 2. That constant will come and multiply the function. All right, so 2 times 4 gives us 8, and 4 minus 1 gives us 3. Okay, so as a beginner, this is how you go about it. But as you advance further in differentiation, you wouldn't have to go through all these stages. Okay, so let's see. If you have a second example, so we have a function f of x is equal to 4x raised to the power half. All right, so the differential of this will be f prime of x is equal to, this is the constant, so we pull it out. Now we are going to differentiate this. Okay, x raised to the power half. So we would write the power down here, which is half. Then we have x. Okay, so we would have to subtract 1 from the power. So half minus 1 is negative half. All right, now 4 times half is what? That is 2. Then we have this. Okay, now from indices we should have 2 over root x. Okay, so this is for the scalar multiple rule of differentiation. Now let's move on to the addition or subtraction rule of differentiation. Addition or subtraction rule of differentiation. Okay, so we may have two functions, f of x and g of x, and we'll be told to either add them up or subtract. Okay, so we might have two functions that we are either adding or subtracting. And the instruction will be for us to find the differential of the resultant. So this is what we do. To find the differential, we put it in the differential notation. Okay, so we have f of x, either we are adding or we are subtracting, then g of x. Okay, but this is what the rule states. Differentiate the first function, which is f of x, and then we add or we subtract, then we differentiate the second function, which is g of x. Okay, so let's solve an example to see how this is done. Example 1. Given that y is equal to 2x cubed minus 5x plus 4. Remember, we have a constant here. We will see how to treat constants in differentiation, okay? So dy dx, all right? Remember that we just treated scalar multiple rule. So we will keep the 2 constant, then the 3 will come down, and then we subtract 1 from the power, which will be 2, okay? So we differentiate this on its own. This is what we have. Then we move on to the next term, which is 5x. Remember that the power of the x is 1, okay? So we have 5 times 1, okay? Then x, the power is 1. We must subtract 1 from the power. Then we have plus what? 4, okay? But remember that this 4 also has an x term, and the x has a power of 0, all right, that we don't write, okay? So this is what happens. You have your 4 times the 0, then x, 0 minus 1, okay? So this will give us 6x squared, then 5 times 1 is 5, and x raised to the power 1 minus 1 is x raised to the power 0. X raised to the power 0 is 1 because any number to the power 0 is 1, which means our answer is 5. Now see this. 0 times 4 is 0, and 0 times x raised to the power negative 1 is also 0. This is the main reason why whenever you differentiate a constant, the answer is 0. So put this one in mind. Differential of a constant is 0. So cleaning this up gives us 6s squared minus 5. Okay? So when you are to differentiate a function involving addition and subtraction, what you do is that you differentiate the various terms separately. Okay? So you differentiate this times that will be 6. Then 1, you less 1 from the power, so you have 2. Then 1 times 5 is 5. Then 1 minus 1 is 0. So x raised to the power 0 is 1. And you are good to go. Let's look at a second example. Y is equal to 7 minus 2x raised to the power 4 plus 4x. Okay? So dy dx, we saw from our previous example that the differential of a constant is what? Is 0. So when you differentiate this, you will get 0. Then you have 4 times 2, which is what? 8. Then you subtract 1 from the 4. You are left with 3. Then the power of the x is 1. So 1 times 4 is 4. Subtract 1 from this power, which will be 0. So you have negative 8, x raised to the power 3. Now x raised to the power 0 is 1. 1 times 4 is 4. Or you can rewrite it as 4 minus 8 x raised to the power 3.